Hi everyone, I am Sandhya from Department of Biomedical Engineering at Erode Singandar Engineering College. Is subject radiological equipments, seminar presentations. The titles are Automatic Exposure Control in X-ray Imaging. This is the introduction. X-ray imaging is one of the most widely used diagnostic tools. Image quality depends on correct exposure of radiations. Manual exposure can cause errors leading to under or overexposures. Overexposures increase radiations dose to patients. Underexposure is a diagnostic image quality. Exposure. Display control panel allows radiographer to set parameters. Types of detectors: ionization chamber detectors, solid state semiconductor detectors. Each detector converts radiations into electrical signals. Ionization chambers are gas filled and measure charge. Solid state detectors are faster and compact. Selection depends on imaging system type and ionization chamber automatic exposure control. Gas filled chamber placed between patient and image receptor. X-rays ionized gas molecules inside the chambers. The generator charges is proportional to radiation dose. The signal is sent to control circuits. Exposure stops once the present threshold is reached. Commonly used in analog X-ray systems and solid state automatic exposure systems. Made from silicon or other semiconductor materials. Convert X-ray photons directly into electrical charge. Faster response compared to ionization chambers. More durable and compact. Common in digital and flat manual detector systems. And provides more precision exposure controls. And next is the automatic exposure control detector. This detector configuration. Detectors may be arranged in single and dual and triple format. Selection depends on the body parts being imaged. For chest x-rays, outer chambers or need of exposure control. Each patient has a different body thickness and density. Manual control cannot adapt quickly to variations. Automatic exposure control helps adjust exposure automatically. It maintains the uniform image brightness and constants, reduces the need of repeated exposure, improves both safety and workplace efficiency. Automatic exposure control is the automatic systems that controls exposure times. It stops X-ray generations when through radiations reaches the detector. It ensures consist image receptor exposure. The system measures the intensity of radiations for real times. And detector measures radiation intensity reaching the image receptor. When preset dose level is reached, the exposure stop automatically. Exposure control is achieved through timing circuits. The system replaces manual timer settings, provides reliable and reproducible exposures. And these are automatic exposure control. Is the ionization chambers and uh, components of automatic exposure control systems. Ionization chambers detect radiation levels. Amplifier circuits strengthens weak signals. Comparator unit compares the detector values with present thresholds. The working principles. Patience is a point between X-ray source and detector. X-rays penetrate the body and reach the AEs, automatic exposure control sensors. The sensors measures radiations intensities. Electrical signals increase as radiation builds up. When present level reached circuit triggers export cutoff. And shows consist image receptor exposure and exposure time control is eliminates manually timing and errors. Exposure times is automatically adjust the patient size. Helps avoid to dark or too light images. Reduces patient dose variability and improves consistency between examinations. Essentially for high volume radiological departments. And factor affecting AEC performance, patient size and tissue composition, positioning accuracy of patients and detector selection for anatomy, collimation of the field size, types of image receptor used, and proper calibration maintenance. And backup timer. Backup timer is act as a safety features of automatic exposure control systems. And terminance exposure is the detector fails to response. Prevents excessive radiation exposure. And typically backup time 1 and 2 seconds. Must always to be set slightly higher than normal time. Ensures patient production during system malfunctions. And density control settings allows a fine tuning of image brightness, provides a -2 -1 and a 0 +1 +2 density levels, adjusts the threshold density of automatic exposure control. These are plus is a increased image darkness and negative is a lighter. Useful is a radiograph customizations. Anatomically programmed radiography is a combines of exposure controls with present exposure programs. Technological selects body region, for example, chest and skulls. System automatically adjusts KVP, MA, and chamber selections. Enhance workflow and consistency and reduces changes of operator errors. Common in modern digital X-ray consoles. Automatic exposure control calibrations. Ensure system accuracy and reliability. Calibration performed using test planar terms must be checked regularly by medical physicians. Deduct deficiencies is reductor sensitivity, prevent image quality integrations. And advantages of automatic exposure control is producers consist of image density and contrast, reduces repeat exposure and radiation dose, improves imaginations and examinations speed and efficiency, enhance patient safety, support high quality diagnostics outcomes. Limitation of automatic exposure systems, positioning errors leads to incorrect exposure, wrong chamber selection, affect brightness, not suitable for small and irregular anatomy, cannot compensate for metal prosthetics or construct media, requires calibration and maintenance, limited manual override options in some some systems. Next is a common errors in uh, automatic exposure system is used. Patient not centered properly over chamber. Improper collimation affecting detector exposure and using incorrect chamber combinations. Exposure of unnecessary areas and troubleshooting techniques. Verify detector alignment and chamber functions. Check calibration regularly and ensure proper collimation and centering. Use correct automatical presets. Quality assurance test. These are reproducibility test for consistency. Density control used for variations. Backup timer, backup timer function verifications. Minimum exposure response time test. And radiation production aspects allows ALRA, ALARA, as allow as responsibly achievable principle. Is a automatically limits unnecessary exposure, reduces repeated scans, and protects both patients and operator, and maintain diagnostics quality with minimal dose, and supports radiation safety and compliance. These are digital radiography for automated, fully integrated into digital detectors. Sensor communicate with the software for real-time control. Provides automatic dose modulations. Optimizes both image and dose. It is a backbone of smart imaging systems. Next, our conclusion is the automatic exposure system is the ensures consist optimizing X-ray imaging, balance image quality and patient safety, requires correct use and calibrations, and integral of modern radiographic systems, promotes radiation safety and diagnostic accuracy. This is automatic exposure control ensures optimal dose, efficiency, reproducible imaging. This supports for AI, DR, and PACS based digital workflows. Calibration is a key, is a sustained accuracy, revolutioning radiology through the automation. And